What are we doing in class on Monday? Quiz, right? A quiz. All right. So here we go. This first problem right here is a function. It's an equation. It's in standard form. And one way that that's really great for us is that it's going to be very easy to see the degree and the a value immediately. We won't have to do any multiplying out first like we did in the warm-up. So the first step on your notes right here, EB, determine the end behavior of the graph. We're going to do that first. The degree is odd. The a is positive. How's that going to go? Down, up. And if you still feel like you have to remember the chart is fine. But I also want to encourage you, if you can only remember what x squared does and what x cubed does, then you can use that information to figure out everything else. So for example, the parent function x cubed goes like this, right? So any odd degree, so the end behaviors are opposite, right? Down, up. So any odd degree, the end behaviors are going to be opposite. So if it was to the 5th or to the 7th or whatever. And what makes it down, up is if a is positive. What changes if a is negative? They just flip, right? So if all you can remember is odd is like this and even is like this, then the rest you can just figure out as you need the information. So you don't feel like you have to memorize that table or that chart. And so in this case right here, it's x cubed, it's odd. The a is positive, so this is going to go down, up. Okay. So the second step on your notes is to figure out the y-intercept. On your skill check, you had to multiply out the last terms because it's in factored form. This is in standard form, so you don't even have to do any math at all. Which of these things here represents the y-intercept? The -4, the constant. And so you already have that information. You don't even have to do any math. So what our goal, remember, is to graph a rough sketch of that equation without using a graphing calculator, okay, without using a table of values. We're going to use essential characteristics. And the two pieces that we have so far is that the end behavior is going to be down, up, and we know that the y-intercept is 0, 4. So here's some characteristics of our graph. It is -4, thank you. Okay, so 0, -4, thank you, Casey. The next step on your note, step 3, is to find the zeros. So again, just as a contrast, here on our skill check, if I wanted to have found the zeros, I would just look at each factor. Okay, this would give me a 0 of +5, this would give me a 0 of -1, and that one +2. Okay? When it's in standard form, like our homework today, we don't have factors, but we can get them. And that's the goal of step 3. We start, and this is from the last unit, we start by using synthetic division to get our x cubed down to something that we can factor. And so looking at this given factor right here, I already know that x + 2 is going to work because the problem tells me so. What number am I going to put in that little synthetic division box? -2, right? If it's in fact, you're putting a 0 here, the root value. So if you're given factored form, you have to change the sign. And then we put the coefficients down. It's missing an x term, so be sure to use 0 as a placeholder. Okay? So you do your synthetic division, I'll do mine. And again, real quick, if you were like, well, how did synthetic division even come into play? Because we're trying to find the factors. And so we're starting with synthetic division to break it down. And you should be getting a remainder of 0 because we already know x + 2 is a factor, which means it divides evenly. So then we have these coefficients, 1, 1, -2. We put our x's back in 1 degree less. And now we have this trinomial to factor. I'm going to use swing on that. If it was 4 terms, I would have tried grouping what multiplies to -2 and adds to 1. 2 and -1, okay? Dividing by your a value doesn't change anything because a is just 1. So these two things right here give me these two factors, x plus 2 and x minus 1. Now that x plus 2 right there, I just got that from factoring. That is a different x plus 2 than the one I started with. So I need to bring that one down and include it. Okay. So those are two distinct x plus 2's. One I got from factoring, one I got at the beginning of the problem. And here's how we're going to use this information. So yes, those are giving me my zeros. That's true. I'm going to rewrite it like this just for a second. X plus 2 squared. But the other information I'm going to use is what we talked about yesterday, the multiplicity of each zero. Because remember, that determines the behavior at that point. Is it going to bounce or is it going to go through? So my zeros are, this factor, x plus 2, gives me a 0 of what? Negative 2. And this factor, x minus 1, gives me a 0 of positive 1. Now, how many times does this x plus 2 factor occur? Twice. Is that even or odd? Even. So the multiplicity of this 0 is even because it occurs 2 times. And the reason why I care about that is, what does the graph do when the multiplicity is even? It bounces, okay? So that means it bounces. It's going to look like a quadratic or a parabola right there. And then for my 0 of 1, how many times does it occur? 1. Is 1 even or odd? Odd. So what's the graph going to do at that point? Go through. It's going to cross. So here's how we'll put that information on the graph. I have a root at negative 2, so that's where x equals negative 2, and a root at 1. So now we have, I think, enough information to sketch a rough graph of this function. We're not going to do step 4 on this one, and I'll explain why when we do step 4 on the next problem. We know that there's a bounce right here at negative 2. I have two options for a bounce there. It's either going to go up or it's going to go down. I have to use some other information to figure that out. What other information do I have that's going to make that decision for me? The end behavior, exactly. So if it's got to go down here, then I know the bounce here is facing down. So one thing about these problems is you really have to use, and this one's pretty straightforward, but some of the more complicated problems, you have to take in all the information that you've gathered and make an informed decision, right? Because remember, these are just rough sketches of the graph. They're not, perfect. Technically, even though I drew the graph turning at the y-intercept, I'm not exactly sure it turns right there. It could go through and then turn a little bit, but it's not going to make a big, because I know it has to come up almost immediately after that point to make it through this 0. I'm not very concerned at that section about what's happening. Okay, but if I was, that's when I would do step 4, which I'll talk about in a second, picking a mid-interval point. And that'll become clear when we try this next problem. What I want you to do on the next problem by yourself for a few minutes is steps 1, 2, and 3. When you get to step 3, get all the way through to the zeros and the multiplicities. I've had a lot of people today, they're just stopping at the factor step, but I don't want you to stop there. Get your factors and go all the way through, figure out what your zeros are, figure out if it's even, odd, or bounce. I'm not expecting you to graph right now. Just get to step 3 and then we'll regroup and talk about it. It's odd degree and positive a, so what's the end behavior? Down, up. What is the y-intercept? 0, 8. And yeah, that's off your graph a little bit, just sort of eyeball it. 0, 8's up there somewhere. Step 3, we want to find our zeros, so we have to start with synthetic division. What number goes here? 4. I'm not missing any x's. Math, math, math. Remainder of 0, perfect. That's what I was looking for. And when you factor this, you get the exact same thing you got in the first one, so don't think you're going crazy. That's okay. If I stopped right here, which factor am I forgetting about? The x minus 4, right, from the beginning. Okay, and so again, that's fine. We have all these factors, and that was some math. Why did I need those things? Because what information do I want from those? The zeros, right? So this gives me a 0 of -2, this a positive 1, that one positive 4. They each occur how many times? One time. That's their multiplicity. Multiplicity meaning how many multiples of each one do I have? Just one. That means their multiplicity is odd, which means the graph will cross when it reaches all of those points. Okay, it's not going to bounce. So I've got -2, 1, and I have 4. Now, if you went ahead and started graphing here, it would look something like this. But here's the thing, and here's why we're doing step 4 here when I really didn't care about it in the other problem. These two x values are sufficiently far enough apart that we can't be sure where it's turning around. Like maybe it's here, or way down here, or maybe it's here where I thought it was. So what we do then is we take a mid-interval point. So this is an interval between these two things. And I take some x value in between there and figure out the point there. So I'd have to find my y value. Now, you can do this a lot of different ways. Okay. I'm going to pick x equals 3, and I'm going to plug that into the original equation. I'm going to do some math. I'm going to find my y. You could have picked 2. If you wanted to be really, really accurate, you could have picked 2.5, okay, because that's like right in the middle of those two things. I wouldn't recommend picking 2.1 because that doesn't seem far enough along to give you any kind of good information. But it is a gray area, and I know sometimes we don't like that. We want one way to do it and do it the same way every time. But it is a gray area, so you pick whatever you like. I'm going to pick 3. So for step 4, I'm going to let x equal 3. Math will occur. And it would give me that y equals -10. Okay? That math that occurs, you put your your 3 in for the x's everywhere you see one, and you just follow your order of operations and simplify, and you'll get -10. So that will give you a good idea of where the graph will turn around, or a better idea. So 3, -10 down here somewhere. Okay, so that's the reason for a mid-interval point. The reason why I didn't take a mid-interval point between these two zeros is because my y-intercept pretty much already does that job for me. Yes, ma'am. Was that your question? Okay. And the reason why I didn't feel like we necessarily had to do that step on problem number 1 is because here's an interval, but they're pretty close together, and this interval's pretty close. I didn't really feel like I benefited from that extra math. But in this case, yes. I really feel like that we needed that information. So any questions about this problem? Yes?
Will we get points off if we don't do that step on certain problems?
I'm going to say yes. But it'd be hard to figure out when I want you to do that right and when not. So I'll try and make it clear in some way. Like definitely take, like I might say, be sure to take your mid-interval points or something like that. I'll try and make it clear that I'm looking for it on the particular problem. Here's what I'm doing with the rest of your homework. I definitely want you to do 61. I definitely want you to do 63 on the back. The rest you cannot do this weekend. And it's because, remember I told you we were running behind and there's some skills that we cut out? You need those skills to do these last 3 problems. So what I think I might do is save a couple for Monday and just work through it with you, guiding you a little more than otherwise if we had those skills. So just those 2. I'll have the key in the back. You may have your music while you work. Don't forget about your quiz on Monday. Yes, ma'am. Just sign out for me, please.